Welcome back to the Deep Dive. Our mission here is to take stacks of complex sources, historical archives, scientific papers, investigative reports, and really distill them into the essential knowledge you need with all the shocking clarity and context intact.
And today, we are embarking on a deep dive into a historical pursuit that really defined post-war justice: the hunt for Dr. Josef Mengele.
And this wasn't just any pursuit.
No, not at all. This was one of the most significant operations to track down a Nazi war criminal, a man known universally and chillingly as the Angel of Death of Auschwitz.
That pursuit spanned, over 3 decades? It involved relentless efforts by American, West German, and Israeli investigators.
It was a search that really haunted the world, mainly because Mengele successfully evaded justice for 34 years after the collapse of the Third Reich.
It's a story that captured the global imagination. It sort of symbolized the unfinished business of the Holocaust. And yet, the final definitive resolution didn't come from a courtroom or a capture team.
No. It came from a handful of highly dedicated scientists in a laboratory.
That's the core of what we're digging into today.
Exactly. The trail, which was kept alive by, sporadic leads and crucially sustained by secret funding from his powerful family in Germany, that trail eventually led investigators to South America.
We now know that Mengele suffered a stroke while swimming in the Atlantic. He drowned on February 7, 1979, near Bertioga, Brazil.
And he was buried under a false identity, an alias Wolfgang Gerhard.
And the mystery persisted even after he was dead and buried. It wasn't until years later, based on information finally uncovered, that the skeletal remains, strongly suspected to be his, were exhumed in June of 1985.
In Buenos Aires, Brazil. And the initial forensic findings were compelling, but for someone like Mengele, compelling wasn't quite going to be enough.
They were strong, though, for the time.
Oh, absolutely. They were using the best traditional methods available in the mid-'80s. An international team of experts conducted these really rigorous comparisons.
What did that involve?
Well, they analyzed dental records, they matched detailed skeletal features against known photographs, and they even performed craniofacial superimposition.
That's where they overlay the skull onto historical photos, right?
Exactly. And their conclusion, after all of that, was that the remains were Mengele's beyond reasonable doubt.
Beyond reasonable doubt? That sounds pretty definitive.
It is, in a normal case. But you have to think about the context here. This was the identification of Josef Mengele. The sheer historical gravity, the global controversy, the decades of failed manhunts.
Right.
Beyond reasonable doubt, based on traditional methods, just wasn't enough to satisfy the world. There were still lingering questions, still a need for independent, definitive, and just unassailable proof.
Proof that could stand up to absolutely any scrutiny.
Any scrutiny whatsoever.
So our mission today is to go deep into the scientific breakthrough that provided that necessary absolute proof. We're focusing on the 1992 scientific paper, Identification of the Skeletal Remains of Mengele, Josef by DNA Analysis.
A paper that truly pioneered the use of emerging genetic technology under really extreme duress.
We're going to explore the stunning technical hurdles these scientists faced, working with highly degraded and contaminated bone, and how this landmark application of forensic DNA delivered final, irrefutable historical closure.
It's an incredible story of science meeting history.
Okay, let's unpack the historical shadow first, because the absolute evil of the man only makes the precision of his identification more poignant.
You're right. To understand the end, you have to understand the beginning. And who was Josef Mengele before he became the Angel of Death?
He was a physician, a scientist.
A highly credentialed one. And that's crucial to understanding his later actions. He was born in 1911 in Günzburg, Germany. Very academically driven. He completed a PhD in physical anthropology from the University of Munich in 1935.
And then a second doctorate.
Yes, followed that up with a doctorate in genetic medicine. His career was, tragically, perfectly aligned with the rise of Nazi racist ideology.
He wasn't just a rank-and-file Nazi who got swept up in it. He was ideologically committed, and from very early on.
Absolutely. He joined the Nazi Party in 1937 and then the SS in 1938. His academic specialty directly served the Nazi state's goals. He worked under a very prominent geneticist, Dr. Ottmar von Verschoor, at the Institute for Hereditary Biology and Racial Hygiene.
First in Frankfurt, then Berlin.
Right. And Mengele became an expert on twins, focusing his research on genetic defects.
So his work wasn't just some abstract academic exercise. It was immediately applied to policy.
Precisely. His research was used to provide the so-called expert opinions that underpinned horrific laws like the Nuremberg laws.
He was providing the scientific facade.
He was a facade for the state's goals of maintaining German racial superiority and carrying out the so-called cleansing of the race. He was a respected, highly trained scientist operating within a system where science itself had been completely corrupted by malice.
And before he arrived at Auschwitz, he actually had a decorated military career.
He did. He was drafted in 1940, volunteered for the medical service of the Waffen-SS, and served on the Eastern Front. He was involved in heavy combat.
And even won the Iron Cross First Class.
An extremely high honor, yes. He earned it for pulling 2 wounded German soldiers out of a burning tank under fire.
It's hard to reconcile that image, a war hero, with what came next. His transfer to Auschwitz in May of 1943 is just utterly chilling.
He was seriously wounded in mid-1942, declared medically unfit for further active service, and after he recovered, he was transferred to the concentration camp service.
And that transfer was encouraged.
It was, by his mentor, von Verschuer, who saw it as an opportunity, a chance for Mengele to continue his anthropological research, completely unimpeded.
He arrived at Auschwitz II Birkenau, initially as chief camp physician for the Romani family camp.
Yes, and after that camp was liquidated in 1944, he was promoted to chief physician for the entire Auschwitz-Birkenau complex.
And he saw this vast human suffering, this endless stream of prisoners arriving, not as a humanitarian crisis, but as a scientific opportunity.
An opportunity without limits. He perceived the 1.3 million people sent to Auschwitz, men, women, children, from every background imaginable, not as individuals, but as an inexhaustible free supply of human subjects for his perverted research.
This is where the name Angel of Death really takes hold, isn't it? His role in the selections on the ramps?
Yes. That arrival platform, the ramp, was the first moment of life or death. He was one of the SS physicians responsible for the selection in.
Deciding who was capable of labor and who was sent immediately to the gas chambers.
And this process was swift, brief, devastatingly superficial. He'd often just use a flick of his wrist, a nod of his head. Generally, about 3/4 of new arrivals, children, mothers with small children, pregnant women, the elderly, the frail, were immediately deemed unfit for labor.
And survivor accounts of this moment, they're all so consistent. They speak of a cold, calculating detachment.
They absolutely do. Survivors consistently noted his calculated, detached, almost elegant, and non-emotional demeanor during these selections.
He would show up even when he wasn't on duty.
Often, yes. He would appear at the ramp, specifically seeking out people with interesting physical anomalies, or, most frequently, twins for his research.
I read one account that described him standing there, deciding the fate of thousands with an almost robotic air, sometimes even whistling a tune.
The detachment is what's so horrifying.
Let's delve into the specifics of the inhumane experiments he conducted. He was trying to validate the pseudoscience of Nazi racial theory, and his obsession with twins was central to that.
It was the absolute core of his research interest, driven by his work on heredity. He focused primarily on Jewish and Romani children. His objective was to find definitive evidence of genetic defects or racial weakness, often by intentionally inflicting damage and then just observing the results.
And the procedures he implemented they're truly difficult to comprehend.
The list of atrocities is staggering. Experiments involved intentional infection. For example, he'd infect one twin with typhus and then subject both twins to blood transfusions, trying to observe how the uninfected twin reacted.
He severed limbs.
Severed limbs, performed gruesome surgeries without anesthesia, and if one twin died, or once the experiment was over, Mengele would often order both children killed simultaneously.
Usually with a phenol injection directly to the heart.
Yes.
Why kill them at the same time? What was the logic there?
The logic, in his mind, was to perform comparative post-mortem autopsies. He needed the bodies of the twins to be killed at the same moment, so that the research materials, the organs, the skeletons, could be compared directly, side by side, in the freshest possible state.
The case of the 2 Romani twins, the ones sewn together. We have to recount that to show the depths of his sadism.
It's one of the most horrifying testimonies. As recounted by a survivor, Vera Alexander, Mengele had 2 young gypsy twins sewn together back to back.
In an attempt to create artificial conjoined twins.
Yes. The children developed massive infections, gangrene, and they died in unimaginable agony after several days. He approached these procedures not with any medical ethics, but with the cold, detached curiosity of a collector seeking specimens.
And beyond the twins, he had this project on eye color.
A collaboration with Corinne Magnuson of the Kaiser Wilhelm Institute back in Berlin. They were obsessed with heterochromia, having 2 different colored eyes.
which they saw as a sign of racial weakness.
Incorrectly, yes. They viewed it as a pathological indicator. So Mengele sought out individuals with this condition and also those with blue eyes, which of course he associated with the Aryan ideal.
And he was using adrenaline eye drops based on a flawed rabbit study.
A deeply flawed study from 1937 suggested adrenaline drops could influence pigmentation. So Mengele administered these drops to inmates, including a 12-year-old Sinti girl, trying to artificially alter their eye color.
But scientifically, it was doomed from the start.
Completely. Conditions like Waardenburg syndrome, which was common in the family he studied, involved a lack of pigment cells. Adrenaline couldn't fix that.
And the failure wasn't just a negative result, it caused real pain.
Oh, the side effects were brutal.
Yeah.
Severe ocular irritation, inflammation, blurred vision, swelling. There are accounts of a newborn baby dying from the systemic effects of the drops, likely from a severe hypertensive reaction.
And the victims he selected for their eye color.
Like Baldwin Michel, they were ultimately killed by lethal injection, their eyes enucleated, preserved in alcohol, and shipped back to Magnuson in Berlin for further histological study.
He treated people like lab rats.
Worse. His interests extended to anyone with congenital anomalies. Anyone who deviated from his concept of the ideal race was a subject.
People with dwarfism, gigantism.
Yes. Those prisoners were subjected to hours of painful and exhausting special medical examinations, detailed physical measurements, drawing massive quantities of blood, extracting bone marrow, unnecessary drugs, constant x-rays.
And the surgeries, the procedures, they were often performed without any attempt at humane treatment.
None. Organ transplants, invasive surgeries, all performed without appropriate anesthesia. The typical outcome was that the victims were allowed to survive for maybe 2 weeks before being killed.
And then the final autopsy.
The final comparative autopsy. Their skeletons or organs were meticulously preserved and sent to collaborating researchers back in Germany. He was, in effect, creating a human specimen collection.
It's difficult to process the scope of this organized scientific malice. It's the complete collapse of medical ethics in service of a lethal ideology.
Let's take a breath and transition to how a man capable of this managed to avoid capture for more than 3 decades.
It is a profound and frustrating chapter of history. As the Soviet Red Army advanced on Auschwitz in January 1945, Mengele fled westward.
And he took his research records with him?
The very materials that documented his horrific actions. He later put on a German army uniform and joined a retreating unit.
And there was a moment right at the end of the war where he was captured and then let go.
A moment with huge historical implications. He was captured by U.S. forces in the summer of 1945. But the Allied system was disorganized. He wasn't wearing his SS uniform, just a standard army uniform. So they failed to identify him as a high-ranking, wanted SS officer.
He had false papers, but it was really a bureaucratic oversight.
A bureaucratic oversight that secured his freedom and gave him the head start he needed. He hid in Germany, living under an alias as a farmhand near Rosenheim until 1949. But the investigators were closing in.
Yes. As U.S. war crimes investigators began systematically tracking down known SS members, Mengele realized he had to get out of Europe.
And he had help.
Financial help from his powerful family, Carl Mengele and Sons. He used the network known as the Rat Lines to flee via Genoa in 1949 to South America.
He landed in Argentina first.
Yes. Started with menial jobs, a carpenter, then eventually became a salesman for his family's farm equipment company. By 1956, he felt safe enough, this is just astounding, to get a West German passport under his real name.
Under his real name.
He even traveled back to Europe, met his son Rolf, who was told this was Uncle Fritz, and spent a week in his hometown of Günzburg.
So he was moving around using his true identity while the world was supposedly hunting for him.
That audacity ended in 1959. He learned that West German prosecutors knew he was in Argentina and were starting the process to seek his arrest.
Yeah.
So he fled to Paraguay and quickly got citizenship.
And then came the game changer, the capture of Adolf Eichmann.
May 1960, the Mossad successfully captures Eichmann in Buenos Aires. Mengele knew then that the stakes had been raised infinitely higher.
He correctly guessed the Israelis were coming for him next.
He did. He fled Paraguay and, again, with the aid of his family network, spent the rest of his life, 19 years, in Brazil, living under the alias Wolfgang Gerhardt.
The Mossad hunt for Eichmann was a success. Why did the attempt to capture Mengele fail?
Well, Isser Harrell, who led the Eichmann capture, definitely prioritized tracking down Mengele right after. They followed initial leads, an address Eichmann had revealed, But Mengele was a much more elusive target.
More paranoid.
Very paranoid, frequently moved, and his safe house leads just went cold very quickly.
So the search wasn't called off immediately.
No, not at all. Aroni, one of the key operatives, led a dedicated team that followed the trail through Paraguay and eventually to a rural area outside São Paulo, Brazil. They even identified a European man they strongly believed was Mengele. It was a major potential breakthrough.
But history intervened.
It did. The Mossad leadership was facing immense logistical difficulties. A deep country capture operation in Brazil is not easy. They had significant budget constraints and a sudden, urgent need to prioritize Israel's deteriorating security situation with Egypt.
So they made a choice.
A difficult one. They called off the manhunt in 1962, and so Mengele lived out his days in hiding, dying by drowning in February 1979.
He died a free man, never having stood trial.
It wasn't until 1985 that investigators, through renewed cooperation between German, Israeli, and U.S. agencies, finally raided a family friend's home in Ginsburg. And that raid yielded the critical evidence that Mengele had died and was buried in Brazil under that alias, Wolfgang Gerhard.
And they followed up on that information. The remains were exhumed in June 1985, and that initial forensic investigation, using the traditional methods, concluded with high confidence that it was him.
But as we said, for a ghost of the Holocaust, high confidence wasn't enough. The world needed certainty.
It's hard to pivot from that sheer magnitude of historical horror, but it is precisely that weight of history, that need for absolute, irrefutable justice that demanded this scientific breakthrough. So let's move to the science now.
The necessity of DNA really cannot be overstated. When Mengele's remains were exhumed, DNA-based identification of old human skeletal remains was, it's just beginning to emerge.
It offered a potential for conclusive evidence that was totally independent of eyewitnesses or historical records.
Absolute proof, beyond any traditional forensic method.
So before we get into the technique, let's talk about the physical evidence itself. What exactly did the scientists have to work with for this unprecedented task?
They received several samples from the exhumed remains. Sections of a femur, a humerus, a scapula, and 2 teeth.
And the condition was not great.
It varied significantly. The scapula, for instance, was severely deteriorated. It's extremely fragile and porous, a sign of heavy degradation.
But some parts were better than others.
Yes, sections of the dense femoral shaft and the humeral shaft showed slightly better preservation, and those are what the team really targeted for the DNA extraction.
The choice of which bone to use and even which part of the bone must have been critical given the challenges of, burial and time.
It is absolutely crucial. Extracting viable, intact human DNA from old, buried bone is so challenging because DNA just constantly degrades over time. It breaks down into smaller and smaller pieces. To really understand how they succeeded, we need to quickly look at the evolution of forensic DNA technology.
Okay, so let's set the scene for the technology.
To appreciate the technical triumph of the Mengele identification, we have to start at the beginning. The pioneering work of Sir Alec Jeffreys in the mid-1980s.
Sir Alec Jeffreys, the man who gave us the DNA fingerprint.
Exactly. In 1985, Jeffreys identified these highly variable repeating sequences in the human genome, which he called mini-satellites, or VNTRs.
Variable numbers of tandem repeats.
Right. His initial technique involved using radioactive probes that would bind to these sequences and that would reveal a unique, barcode-like pattern of bands for nearly every individual.
And this initial technique, known as RFLP, was incredibly powerful. It provided definitive proof in some really famous early cases.
It did. It established kinship in an immigration case and famously identified the killer, Colin Pitchfork, in the UK double murder case.
Those pioneer cases really showed the potential.
They absolutely did. But the RFLP method worked well when you had relatively fresh, non-degraded samples, like liquid blood or semen stains.
But RFLP had a critical limitation when you tried to apply it to older evidence, like Mengele's bones.
It did. Because those mini-satellites are long, repetitive units, RFLP needed DNA strands that were fairly long and intact. When you have samples that are highly degraded and fragmented like bone buried for 6 years in a moist tropical environment.
For fragments are just too short.
Exactly. RFLP simply won't work because the fragments are too short to contain the entire sequence the probe needs to bind to effectively.
So, given the poor state of the remains, what was the technical breakthrough that had to happen next to make identification even theoretically possible?
We needed the invention that changed molecular biology forever. The polymerase chain reaction, or PCR.
The chemical photocopier for DNA?
That's the perfect analogy.
So explain the power of PCR in this context for someone who isn't a geneticist.
Okay, think of it this way. The original RFLP technique needed a long segment of rope to analyze.
Yeah.
If that rope was shredded into tiny threads, RFLP was useless.
Okay.
PCR, however, allowed researchers to target specific, incredibly short stretches of DNA and amplify that tiny amount, exponentially making millions of copies from almost nothing.
So it turned trace evidence into usable evidence.
It was the key that unlocked the ability to analyze trace amounts of highly degraded human DNA.
Now, even with PCR, they needed the right targets in the genome, ones that were short enough to survive that severe degradation, which takes us to microsatellites.
Yes, the technological shift was from mini-satellites to microsatellites, often called STRs or short tandem repeats.
And the key difference is the length.
A huge difference.
Yeah.
Mini-satellites had repeating units of maybe 6 to 100 base pairs. Microsatellites are much, much shorter, typically only 1 to 7 base pairs long, just repeated many times over.
So the logic is elegant in its simplicity. The shorter the sequence you need to find, the more likely it is that that sequence survived intact within the severely fragmented DNA.
That's the critical advantage. The small unit size of STRs means that even if the entire DNA strand has been chopped into pieces only 150 base pairs long, you still have enough intact sequence around the STR marker to amplify it successfully using PCR.
And the Mengele case used these STRs.
It utilized these short, repetitive, CA repeat microsatellite loci, marking a crucial validation point for this technology. They needed the most robust, shortest targets possible.
This is where we get into the truly fascinating part, the scientific deep dive into the 1992 paper itself. Let's trace the incredibly painstaking journey the researchers took to isolate Josef Mengele's genetic identity from a handful of bone dust.
The preparation itself was so meticulous. The first hurdle was contamination. To minimize the risk of contamination from the environment or previous handling, the scientists took the bone samples.
Specifically, 74 grams from the femur and 37 from the humerus.
Right. And they literally removed the surface layer by sandblasting them.
Sandblasting bone, that seems extreme, but I guess it's necessary to remove surface microbes and any residue from handling.
Exactly. It's an essential step in ancient or environmental DNA work.
Oh.
After that, the cleaned fragments were ground into a fine powder in a refrigerated freezer mill.
To maximize the surface area for the extraction.
Precisely. To release the DNA bound within the bone matrix.
And once the materials had extracted, the contamination problem was immediately apparent, wasn't it?
It was immense. When they analyzed the total extracted DNA, they found copious amounts of genetic material. But they estimated that the vast majority, around 99.87% of the total DNA, was non-human.
So environmental contaminants, bacteria, fungi from the burial site had just thoroughly infiltrated the bone.
Absolutely. The actual human nuclear DNA yield was minute. They detected only about 40 nanograms of human DNA in the successful femur extracts.
Which is what, 0.13% of the total genetic material present?
A tiny, tiny fraction. And this tiny fraction was, as they feared, severely degraded, with a mean single-stranded size of only about 150 nucleotides.
Which meant conventional RFLT was instantly out, reinforcing the need for that STR-PCR strategy.
Finding any usable nuclear DNA under those conditions is a feat in itself.
And did the different bone types perform equally? You mentioned they used the femur and the humerus?
No, and this revealed a key lesson about bone DNA analysis that still holds true today. The yield is highly unpredictable.
Really?
The femur extracts, which they labeled F1 and F2, successfully yielded that detectable human nuclear DNA. In stark contrast, the humerus extracts, H1 and H2, yielded virtually none.
So less than 0.005% of the total DNA was human in the humerus?
Basically nothing.
Wait, why would two bones from the exact same person buried in the same grave show such a massive difference in preservation?
It likely comes down to microenvironmental differences. The density of the bone, the specific contact it has with the surrounding soil, differences in moisture content, or even slight variations in temperature or microbial activity can all affect the degradation rates.
So the femur, being a dense, weight-bearing bone, probably just offered a little more protection.
It often provides slightly better protection for DNA trapped inside its mineral matrix compared to the humerus or certainly a fragile scapula.
So this illustrates the difficulty. But even after finding this tiny degraded thread of human DNA, the researchers faced another critical chemical obstacle that prevented the PCR from running properly.
That's right. This is where the triumph becomes truly technical. The extracts contained a potent, uncharacterized substance that acted as a PCR inhibitor.
What's an inhibitor?
They're common in environmental samples. They can be humic substances from the soil, metal ions, other chemicals. Essentially, the inhibitor chemically gums up the amplification process. It blocks the DNA polymerase enzyme from doing its job of copying the human DNA.
So you have a perfect chemical photocopying machine PCR, but the paper is jammed because of the gunk that got extracted along with the DNA. How do you unjam the machine while still having enough original material left to copy?
That required extreme precision and a painstaking process called titration. They couldn't just clean the extract more, because that risked losing the minute amount of human DNA they had.
So what did they do?
They had to find the exact point where they diluted the extract just enough to reduce the concentration of the inhibitor below the level that stopped the reaction, but not so much that the concentration of the target human DNA became too low to detect.
That sounds like threading a needle in the dark.
It absolutely was. They found that they could only use a tiny volume, zero point 0.2 microliters per 50 microliter PCR reaction. Any more, and the inhibitor blocked the amplification.
And to ground that number for us, what did that tiny successful bit of extract represent in terms of actual genetic material?
That zero point 0.2 microliter aliquot, coming only from the successful femur samples, was equivalent to only 240 picograms of human DNA.
What is that in real terms?
For context, that's about the amount of DNA found in 40 diploid genomes. It's roughly the amount of DNA you'd find in a single human hair follicle.
Wow.
They were amplifying the historical confirmation of Josef Mengele from the bare minimum required to even attempt the test.
Absolutely incredible. So, with the amplification successfully established, how did they transition from a profile of STR markers to definitive proof of identity?
They employed reverse paternity testing or kinship analysis. They chose 10 different CA repeat microsatellite loci, strategically distributed over 8 different chromosomes.
And they picked those specific loci because they were known to be highly variable.
Exactly, which increases the statistical power of the test.
And the necessary reference samples were supplied by Mengele's living relatives.
Correct. DNA was prepared from blood samples collected from Mengele's adult son, referred to as R, and his wife, I, who was R's mother.
And the scientific goal was simple.
Determine if the genetic profile extracted from the degraded femur fragment was biologically compatible with being the biological father of R, given the mother's known DNA profile.
And the qualitative results were completely unambiguous.
They were. Across all 10 microsatellite loci they analyzed, using those successful femur extracts, the DNA profile was found to be fully compatible with paternity of Mengele's son.
Meaning every genetic marker that R inherited from his father was present in the profile from the bone.
Exactly. There were 0 paternal exclusions found.
That's the qualitative match. But the ultimate power of this evidence lies in the statistics, proving this couldn't just be some other random person.
This is where the case truly became irrefutable. Because they had to rely on a larger number of these shorter STR markers, they needed the cumulative statistical power of all 10 loci working together.
What was the initial probability of a random match?
Based on standard Caucasian allele frequencies, they calculated the cumulative probability of non-exclusion. The chance that an unrelated Caucasian male would randomly match this specific 10 locus profile to be 2.8 times 10 to the minus 5.
So 1 in about 36,000. For a 4-decade manhunt for one specific man, that's already incredibly compelling.
But the scientists were rigorously conservative.
Yeah.
They recognized that in the early 90s, the population databases they were using were relatively small, which could introduce some statistical uncertainty.
So they accounted for that.
They did.
Oh.
To account for it, they recalculated the probability using the maximum upper 95% confidence limit for each allele frequency. They essentially introduced the largest reasonable margin of error to make the result unassailable.
So even accounting for the maximum possible uncertainty.
Even with that extreme margin of error factored in, the cumulative non-exclusion probability remained remarkably low, 5.6 times 10 to the minus 4.
And what does that mean in plain English?
It translated into the final defining statement that settled the history books. 99.94% of the Caucasian population was excluded as a possible source of the DNA, confirming that the remains were irrefutably those of Josef Mengele.
The technical sophistication required to pull that definitive piece of information from a tiny, degraded, contaminated fragment of a femur is just breathtaking. It provided the ultimate scientific confirmation to a historical search that had frustrated investigators for decades.
And the successful identification of Mengele in 1992 by Sir Alec Jeffreys and his team was not just a successful history project. It was a foundational moment for forensic science.
It was a massive validation.
A massive validation for the use of emerging PCR-based DNA technology, specifically short tandem repeats. It proved they could function even under the most challenging real-world forensic conditions.
It effectively placed the STR-PCR method squarely on the map alongside those other foundational cases that validated DNA typing early on.
Precisely. You see the Mengele case mentioned in the same breath as the 1985 immigration case, which confirmed the power of kinship testing.
And the 1986 UK double murder case.
Yes, where DNA fingerprints using the older RFLP method first exonerated an initial suspect and then identified the true killer, Colin Pitchfork. These early successes demonstrated that genetic profiling could, quite literally, solve the unsolvable.
And the refinement of SDR-PCR methods that this case honed quickly transitioned from these niche, high-profile projects into the standardized, routine tools we rely on globally today.
The utility and robustness of short tandem repeats proved so effective that they became the indispensable backbone of national and international law enforcement databases.
The prime example in the U.S. being CODIS.
The Combined DNA Index System, or CODIS, established in 1994.
How does CODIS operate using the STR system?
CODIS is the standard for the U.S. today. It relies on a standardized set of core STR loci, currently 13 of them, that are amplified from forensic samples. It maintains two primary indexes.
The forensic index and the offender index.
Right. The forensic index contains profiles from crime scene evidence, and the offender index has profiles of convicted offenders. The system uses those 13 SPR profiles as unique identifiers to link crimes together, or link a crime to a known offender.
So the principles that proved Mengele's identity are the same principles solving countless crimes today.
Exactly. And what's truly amazing is how a technology developed for criminal justice and historical resolution has crossed over into critical medical applications.
It's fascinating the sheer versatility of STR analysis beyond the crime lab. In medicine, it's now routinely used in clinical applications, especially for monitoring bone marrow transplants.
Yes, allogeneic bone marrow transplantation. It's used to detect what's called chimerism.
Which is the presence of two genetically distinct cell lines in one person.
Exactly. After a transplant, doctors need to ensure the recipient's blood cells have been successfully replaced by the donor cells. By comparing the STR profiles of the patient and the donor, they can measure the ratio of donor to recipient cells in the patient's blood over time.
And if the recipient's original cells start to reappear.
That's critical. Detecting mixed chimerism, where a significant portion of the patient's original cells return, can often signal an impending disease relapse or the beginning of graft rejection.
So it's a highly sensitive warning system for physicians.
It is. And it's also used after solid organ transplants, like liver transplants, to monitor for donor lymphocytes that might cause graft versus host disease.
That's a powerful tool for patient management. I also saw it's used in a completely different medical setting, the anatomic pathology lab, for sample integrity.
This is a crucial practical application that speaks to the need for quality control in high-stakes environments. STR analysis is now regularly used to resolve cases of specimen mislabeling, misidentification, or contamination. Pathologists sometimes refer to contaminants as floaters.
The floater problem. Tell us more about that.
Okay, so imagine a lab processing hundreds of tissue samples a week. Occasionally, a tiny extraneous fragment of tissue, a floater, might accidentally end up on a microscope slide or in a paraffin block containing the primary patient sample.
Right.
So if a pathologist finds multiple tissue fragments, say a benign polyp and a fragment of invasive adenocarcinoma, they have to be absolutely certain they both came from the same patient.
So STR analysis can confirm the origin.
Definitively.
Yeah.
By comparing the STR markers of the questionable tissue fragment against the patient's known genetic profile, usually from a blood sample, this ensures the correct diagnosis is assigned to the correct individual.
It's quality control, ensuring that one tiny piece of tissue doesn't lead to a catastrophic misdiagnosis. And finally, the foundational application we started with, complex human identification.
Yes, the methodologies refined during the Mengele case are directly transferable to modern complex human identification challenges. From routine paternity tests to large-scale disaster victim identification, or DVI, efforts.
Like identifying victims of major air crashes or natural disasters?
Exactly. And it's also critical in the recovery and identification of unrecovered war casualties, where the remains are often fragmented and severely degraded, much like the Mengele bone samples. The techniques developed to identify this one monster now ensure dignity and closure for countless families.
What an incredible trajectory we've traced. It started with one of the most infamous escapes in history, a man fleeing the collapse of the Third Reich to die anonymously on a remote Brazilian beach. And it concluded with the quiet, definitive confirmation offered by 240 picograms of DNA pulled from a femur shaft.
The Mengele case was a truly rigorous, defining test case for forensic science. It validated the ability of these emerging PCR-based techniques, specifically using short tandem repeats, to function under extreme conditions. Minimal yield, profound degradation, and massive contamination.
That success essentially fast-tracked these methods into mainstream forensic use worldwide.
It really did.
That single, irrefutable piece of evidence confirming the identity of the man responsible for unimaginable horrors at Auschwitz finally brought scientific closure to a chapter of history that desperately needed it.
And here is the final provocative thought we want to leave you with. Josef Mengele, the man we identify today, dedicated his entire warped scientific career to the perversion of genetic science. His obsession with heredity, with twins, with congenital anomalies was scientifically bankrupt and motivated entirely by an extreme, lethal ideology of racial supremacy.
He used perverted science to commit his crime?
He did. So given that he was finally and definitively unmasked using the very cutting edge of DNA genetics, the field he corrupted, what does this ultimate definitive identification reveal about the moral neutrality and the eventual necessary triumph of true scientific inquiry over ideological extremism?
Something to consider as you process this deep dive. Thanks for joining us.